So hello everyone and welcome to today's Leetcode daily question, that is jump game. So you have been given an array nums. So you are initially positioned at the first index of the array and your target is to reach the last index here. So you have to return whether it is possible to reach the last index from the first index or it is not. And what have you been given in the nums integer array? At every index you will be given the maximum amount of jump or the maximum jump you can take from that index. Like here, for I equal to 0, the maximum jump is 2, that is you can move to at max here, that is I equal to 2. And also you can also jump to 3, but the maximum you can reach is 1, this one in this index. Similarly, for the next index, that is I equal to 1, the maximum jump is 3, that is you can at max reach 4. And also you can take less than that, that is you can reach this one or this one. So I hope you have understood the question. So this is, we have to just return whether it is possible or not to reach the last index from the first index. So talking about the approaches, basically this question can be done easily by using recursion plus dp. So this is the solution of recursion plus dp, wherein first of all I will so there let me say this, that there are three approaches. First one is recursion plus dp, second one is a tabulation format, and third one is space optimized solution. So coming to the first one, that is recursion plus dp, that is memoization. So in this we will declare an dp array same as nums dot length. Then I will fill the dp array with -1. Then I will call the recurse function, and whatever I will get at the end from the recurse function, I will return it. So what does recurse function takes? Recurse function takes nums array, the current index, and a dp array which we just created. So currently we are at index 0, so 0 will be passed as an index, and it in return it will return a boolean, that is a true or false. So first of all, it will check if we have reached the last index, that is our target. So we will simply return return a true. If we have exceeded the nums dot length parameter, so it will return a false. If we already have a value in the dp array, so we will simply return that. That is, if dp of I is not, I index is not equal to -1, so we will simply return if it is true or not, that is if equal to 1 or not. So dp will contain two values, that is 1 or 0. 1 means yes, it is, we can reach the last, from that position we can reach the last index. And if dp of idx is 0, that means we cannot reach. So that's why I've written dp idx equal to 1. So if it is equal to 1, so we will, that means it is a true, or else it is a false. Next, what I will do, if the dp does not that is, it contains -1 and it has not been filled with 1 or 0, so what I will do is I will iterate through the I will take I equal to 1 and I less than nums idx. That is, I will go through all the jumps. Like in this we had a 2, right? So I will take I equal to 1 and I will move from I will move to all the possible indexes we can move from this index. That is, it can move to 3 and 1. So first I will go to 3, then I will go to 1. So this was the recursion. Yeah, so I was explaining that I will iterate through all the possibilities from that index at which we can reach to other index. Then if any of this will return a true, so I will simply put 1 in dp of idx. That means we can also reach from this index to the last index, and I will simply return a true. Else, if all the possibilities the none of them return a true, then I will simply put 0, that is false, and we return a false. So this is how recursion goes. Now let me explain you this solution. Okay, so I've pasted the code over here. So let me explain. So this is the nums array. This is the question given to us, and this is a dp which we just created and filled with -1 using arrays.fill dp -1. So coming to the first one, so we will call this recurse function with nums, and index initially will be 0, and dp array will be passed. Okay. So first of all, okay, the index is equal to nums dot length -1. No. since 0 is not equal to 4. So okay, now index is not greater than nums dot length minus 1, so we will move to next one. dp of index, that is dp of 0, is not equal to minus 1, but it is equal to minus 1, so we will move to the next part. Now here the main thing comes. So now what I will do is, I have in nums index, in nums idx we have 2. So I will to go to all possibilities from this index, I will have to iterate and loop from I equal to 1 to I less than equal to nums dot I less than equal to nums of index. That is, I from here I can move from 0 plus 1, that is 3, and from here I can also move from 0 plus 2, that is 0, this element. So that's why we have to start from 1, since if we start from 0, so 0 plus 0 will be nothing, it will be same index. So we will start from 1 and it will run till less than equal to nums index, that is less than equal to this element, whatever is possible jump allowed to us. So okay, so from like here, first I equal to 1, so I will move to next index, so that is I will call a recurse function again with nums and dp, but here the index will be idx plus 1 plus I, sorry, idx plus I, and I was 1. So here I will call the idx plus I, that is 0 plus 1, that is 1. So I will be at this position, that is 3. So okay, so I am at 3 now. Now again what I will do, I will go through all this, and all this will be we will not go to into this because the condition is false. Then again I equal to 1, I less than equal to 3, so minimum I equal to 1, so 1 plus 1, that is 2. So now we will move to this element 0. Now since this element, now if I again index will be 2. So now here I equal to 1, I less than equal to nums of index. Now nums of index is 0 and 1 is less than 0. So this we won't go in this loop, and at the end we will, what we will store is dp of idx equal to 0. So now what does dp of idx equal to 0 means? That we cannot reach the last index from this index. So this will turn into a 0. Now dp of idx, that is dp of 2, is 0. Okay, and return a false. Okay, so now what it will do, it will return a false to 3. So sorry, we cannot reach to last index using the 0, the first, that is the 0 index, that is the second index. Now what we will do is, now I was equal to 1 for this, now I will be equal to 2, and from here now we will move to this element. Now from here again a loop will start, I equal to 1, I less than equal to 1, since nums of index is 1. So now it will again move to 4. Okay, now 4 is the last index, so idx is equal to nums of length minus 1, so we will simply return a true. So this will return a true to 1. Okay, that means we can reach the last index from this number. So if recurs, that is if this the value returned is true, that is a recurse function will return a true, so we will store a 1 and return true. So since we get true from 4, so this 1 will store a true, that is one element number 1, and it will return a true from where it was called. So this 1 was called from 3. So now 3 here also it will get a true from 1. So here we will store a 1. Then since this was called from 2, so here this will be again stored as 1. Now we have a 1, so since we got a 1, so we will return that 1 again. So it will return a true to back to the main function, and since no more calling was needed, so it will return a true and we can reach the last index. So this is how recursion plus dp works. So actually dp didn't we didn't use in this example, but it will be used if we go to an index multiple times. If I go to this index multiple times, so I already have a answer for this, so I did not go again make a call from here. So that is why dp is needed over here. So coming to the next solution, that is tabulation. So this is the tabulation solution. So here we will again declare a dp array, but this will be a boolean array. And then here the difference is that we will start from the end index, that was the target index, and we will move to the first index, and the answer at the end will be contained in the first index, that is true or false. So we will the last index is the target, so dp of nums dot length minus 1 will be true, because of course we, if we are at that position, so we can, of course we can go to that position itself, since the position is same as the target. So now we will iterate through I equal to nums dot length minus 2, that is the second last index, to the I equal to 0, and we will decrement I. Then for each index what we will do is we will declare a flag false. Then we will move forward, uh, like we will move to all the possibilities we can move from that index, that is the highest jump, and we will see if any of this is true, so we will make the flag true, and we will store that flag, else it will be a false, since initially it was declared as false. So let me explain you how to use this. So I've pasted the solution. So we have declared a dp array. Then what we will do, we will store true in the last index. Then we will move from second last index to the first index. Okay, so now for second last index, now here flag will be false currently. Okay, flag will be false. Then uh, we will, from j equal to 1, j less than equal to nums I, similar to what I explained in recursion, we will start from 1, and it will go on till the maximum possible jump we can take. So I equal to 1. So if now j is equal to 1 and I is equal to nums dot length minus 2, so that is 0, 1, 2, 3 and 4. So j is equal to 1, so 3 plus 1, that is 4, and the 4, that is dp of I plus j, that is dp of 4 is true. So flag will be true and will break, and we will store the flag. So that is, yes, we can reach from index 3 to index 4. Now we will move to the second the next previous index, that is 2. Then again the same thing we will do is that j will be equal to 1, and then j less than equal to nums of I, that is 0. So 1 is not less than, 1 is greater than 0, so it, we won't enter this loop, and the flag will remain false, and we will store the flag, so it will be a false. Then again for the next I equal to 1, now here we can move j equal to 1 till j less than equal to 3. So okay, the first one, j equal to 1, so 1 plus 1 is 2, and in the dp of 2 is false. Okay, we will try another thing. Now j will be equal to 2, so 1 plus 2 is 1 plus 2 is 3, dp of 3 is true. So okay, we will store a true, and we will break. So no need to go to the highest possible jump, that is dp of 4. We will store a true. Okay, now next is 0th index. Again j equal to 1, so first jump itself we see it is a tick, so we will take it, and at the end what we will return is this index, that is dp of 0. So dp of 0 will be returned, and it is a true. So this is how tabulation works. So now let's come to the next, that is space optimized solution. So this is the space optimized solution. So what we will do in this is that we will declare a variable called jump, and n will store the nums dot length minus 1, and if the nums dot length nums dot length is 0 or 1, we will, if for 0 we will return a false, for 1 we will return a true. Then what we will do is we will simply iterate through the second element till the last element. Okay, so we will skip the first element. So in every index what we will do is we will store jump is equal to mat dot max nums of I minus 1, that is the previous element in the nums, and the jump, and we will subtract 1 from it. Now if jump is less than 0, so we will return a false, that is in any ways we cannot reach the last index, so this will be returned as the false to the main function. Okay, and else if we are, if at any index we do not get jump less than 0, so it was successful, so we will return a true. Okay, so let's start with I equal to 1. So for I equal to 1, we have jump equal to 0 as it is initialized as 0. So jump is store maximum of nums I minus 1, it is 2, since we are at index 1 currently, or 0. So in the maximum is 2, so minus of it, that is minus 1, so it will simply store a 1. So 1, and since jump is 1 and jump is not less than 0, so we will not return a false. So now jump was 1. Okay. Now for 2, now maximum of 1 and 0, maximum of 1 and 0 is a 0. So sorry, maximum of 1 and 0 is a 1, and negative minus 1 is, so 1 minus 1 becomes 0. So jump will be 0, but since jump is not less than 0, so we will continue. So jump will has become 0 now. Now at I equal to 3, we have maximum jump equal to maximum of 1 or 0. So 1 maximum of both is 1. So 1 and minus 1, that is 1 minus 1 becomes 0. So again jump is not less than 0. We move to the next element. So here we have jump is equal to maximum of 4 and 0. So it is of course 4, and 4 minus 1 is 3. So 3. Now we have successfully executed all the indexes till less than I less than n. So at the end we return a true, that is we can reach the last index. So this is how the space optimized solution goes. So now let me paste it and check if it works. So okay, this is working. So the space optimal solution is working, and also I had previously submitted the recursion solution and also the tabulation solution. So this was how it goes. So I hope you liked the video, and I hope you understood all the three approaches. So thank you for being with me, and do like and subscribe my channel if you liked it, and also do comment if any doubt, and thank you very much.